thank you very much. This is almost the end of the day now, the second time on stage. It feels good to have the co-organizer have the confidence in me to believe I can perform well twice. My talk is titled Knowing Your State Machines. And I want to do this talk because I believe web developers only cares about echoing out HTML really fast. They don't care about fancy programming algorithms or data structures or design patterns. So I want to give you a way to make your code a little bit more structured. And I didn't bring any state machines with me. It's not something I can have in my pocket. It's more, a state machine is more a thing that holds states. It could be anything. It could be like the status of a pull request. It could be the small light indicators on your washer machine. It could be a traffic light. So it's basically a way of thinking and a way to relate to your problems. Yeah, also, if you have that kind of manager that you have to convince, this is like the arguments word. I won't have this much text in my next slides. And you know me from this morning, so I don't. And I usually show this picture like, ooh, just as I did this morning. It's even more, ooh, as it usually be. However, for the last kind of year, I've been taking a break a little bit from open source. I've only been doing things when people ping me like, hey, Tobias, you really need to do this thing. So I've been on vacation and enjoying myself. And the reason I'm showing you these pictures is I want to make this trip deductible. Okay, whenever I make a lame joke, you need to laugh. Thank you. So let's get started. I want to start with some theory and some more theory, then I'm going to show you like a bunch of examples. And I hope you're okay with that because I prepared slides for this process. So let's start with graph theory. The first thing you need to know about graph theory is that these are not graphs. These are charts, these are diagrams, these are pictures, you can call it whatever you like, these are not graphs. A graph has a node. A more interesting graph has more nodes. Nodes can be connected to an edge. An edge is either undirected or directed, and an edge can also have a weight. Are you comfortable? How many of you knew this from before? It's a little more than half. That's excellent. That's what I expected. So consider this graph. This is a full feature graph. It could represent anything. It could represent computers in a network. It could represent people and how well they know each other. It could represent cities and roads between them. And if you slap on some numbers on this, we could ask a question. Maybe say that these are computers in a network. If I want to send data from A to B, what is the maximum capacity I can send? And that's called the maximum flow problem, and there are well-defined algorithms solving that. Or if I ask another problem in this graph, say there's cities and distances between them, what is the shortest path from A to B? That's like there are plenty of algorithms explaining that as well. And let's have a different problem. Say that you're working with landscaping or whatever. You want to have a line of water between each cities. What is the shortest distance you have to put on your pipes? And that's the minimum spanning tree. Oh, I did this in wrong order. Forget what I said. Say that you're a traveling salesman. You're going to visit all the nodes in the correct. You're going to visit all the nodes, and you wanted to have the cheapest path visiting all the nodes, all the cities. That's a traveling salesman problem. And now imagine you're a landscaper. You're going to put on pipes. Like this is the minimum spanning tree. The point I was trying to make is, I am trying to make is, if you have a problem, and if you can express that problem as a graph problem, there's probably already a solution to it. So your issue isn't like to solve your problems, the issue is to convert your problem to a graph problem. And that's like the 3 minutes version of graph theory. So a graph theory is like this big thing that you should be aware of, and now you all are aware of it. One thing about graphs that are interesting for this topic is you can reduce them. We reduce is a mathematical word in this case. So consider this graph. If we reduce this graph, which means we add some constraints to it, then we get something differently. So if I decide to remove all loops in this graph, I'll get a tree. And there's a bunch of problems or and algorithms that you can apply on trees. A very, I wouldn't say common or normal because I've never used it, but one thing you can do with trees is you can have them as a data store. So there is a thing called a red and black binary search tree. Basically, if you are smart how you place your data, you can find it really quickly. So I'm saying it's a bunch of problems or solutions you can do in trees. And trees is not a part of this big graph theory. Another part that I want to talk about is this part, the workflow thing. So a workflow also has nodes and edges, but we've decided, or someone, mathematician decided, that a workflow, we call them places and transitions. And the edges between the nodes are called arcs. Places, transitions, and arcs. And we'll have some restrictions here. We say that two places cannot be connected. It has to be transitions between them. So I'm going to draw this like this. So with these restrictions, we now have a workflow. An example of a workflow could look like this. If you are in place A and do transition T0, you will get to C. If you are in place B and do transition T1, you will get to C and D. Good. We continue adding transitions. Like the theory is almost over, I promise. If we continue adding restrictions, say that a transition can only have one input and one output. Like you see T1, there's one input and two outputs. If I had this transition, only one input, one output, we'll get something like this. And now we finally got to a state machine. This is the definition of state machine. It's a state machine is just a graph that we have reduced plenty. And since I'm drawing this by hand, I'm going to use a slightly different annotation. So if you are in B and execute T1, you get to D. If you are in B executing T0A, you get to C. It's fair enough, very simple. You have this big graph, you reduce it to a workflow, you reduce it to a state machine. Excellent. Theory is done. So let's consider a state machine. This is an actual state machine of a traffic light. It has three states. It has green, yellow, and red. And it has arrows between those states to describe how you can move, right? So you can easily move from green to yellow to red, but you cannot move from red back to green because there's no arrow. So this state machine defines the states and how you can move between states. I work at Happier, and it's basically a job platform. And so we have a lot of job AdWords for our customers. We decided on the business meeting that a job AdWord state machine should look like this. You have draft, you have review, trash, publish, and archive. In draft, you can send it to review, then you can trash it, untrash it, send it to review again, and then you can publish it, and then you can send it to archive. This is what we decided in a business meeting. I think you're getting a hold of this now, so I'm going to ask you a question. Hey, what is this state machine of? Someone whispered at the front. Do we have it in the back? I didn't hear you, but I will pretend you said the pull request. So basically, I believe that the people in GitHub has sat down in a business meeting and decided this should be a state machine with a pull request. So you start coding, and then you send it to Travis. Travis runs for a while, and then it goes to review. You can update your code, so you go back to Travis, and then it goes back to review. Probably someone require you to change something, you go back to coding, then Travis, review, and then again get rejected and reopened, and then accepted. Okay, I'll give you another try. What is this a state machine of? One more time. A knife? I believe you said some doors, right? So basically here, you all know doors. They can either be open or closed. There is no set of doors that go from closed and open directly. They are closed, and then you press the open button to be the doors are opening for a while, and then they're opened. And when it's open, you can press the close button, it'll be closing for a while, and it'll be closed. And if you press the open button, then be opening, and you interrupt this, pressing the close button, it'll be closing again. Make sense? So this is the 4 states a set of doors can be in. You can also do this you can also have state machines with forms. Like say you have a multi-step form, and you can have a state machine that makes sure that keeps track of the last completed step. So if the user goes to A, B, C, and then leaves your site for a while, when it comes back, you can say, hey, you should go to step C. So this could be controller action in your application. You can also have another state machine keeping track on where the user last were. Like you went to A, B, C, D, and then went back to C. So you can keep track on where the user last completed and where the user last visited. And this can also make sure that no user can go A, B, and then jump directly to E, just by hacking URLs or whatever. So I think you all get like a good sense of what a state machine is, and that's just basically just a graph, and you can draw circles on the board like this. So let's start implementing. Let's consider implementing it. There are 2 implementations of state machines. It's the more state machine, and it's the Mealy state machine. And the more state machine using the state pattern. I gotta be super, not technical, but maybe theoretical now. So the more state machine, the next state depends only on the current state. In the Mealy state machine, the next state depends on the current state and some input. And if we are mathematicians, we would look at this and think, oh, I see, the Mealy state machine is way more flexible because it has some extra input. Since I'm a computer scientist, I would like, yeah, it's pretty much the same. It's 3 parameters and that's 2. But in a mathematician way, this is way more flexible, and I'll show you. So let's start with the more state machine and the state pattern. So I gotta implement this now. In the state pattern, you have 1 state machine object, and you have 1 object for each state. The state himself decides what to do and where to move next. So I want to build an application where my user signs up, and there's like 5 different steps in signing up for some reason. And if the user disappears, I want to send them email messages saying, hey, you forgot to add your name, or hey, you have to upload your pictures, or hey, you have to add your Twitter handle, etc. So I want to have a worker that sends those emails. So the state machine basically looks like this. And since it's a more state machine, it's only have 1 method and everything, so everything is send. So the idea, I mean, bear with me now. The idea is to have a worker looking something like that. Like getting all the state machine from the database somehow, and then you start them off. Start them off and send some emails. I don't care which email you send, I don't care which state you're in, but the worker makes sure that we send something. The logic of what to do is in the state themselves. So I start a state machine, and here I'm just getting the state. I call send, because that's the only method the state got. I send it, and whenever I return false, I just stop sending. Don't look too much on the code. I'm basically kicking this off. And each state, in each state object, this is where the logic is. So I'll have my send method, and the send function decides what to do, what email to send, and also where to go next. I may want to add some logic here. I may want to add something like, but ooh, you shouldn't add your name if you already have a name. So I add something like checking, ooh, if the user have a name, go to this state. If not, send the email. But also, I don't want to flood the user with hundreds of emails the first minute, so maybe we're going to do something like this, like, if you have been to this state for more than 7 days, then send the email. Does it kind of make sense? Not crystal, but kinda. And then I add a bunch of names like a bunch of states like this. Add your name again, and add your resume, and add your profile picture, and yada yada yada. And then with all this logic, I can finally write my worker like this. So let me quick summarize the state pattern. You have one class for each state, one method in all states, and each state defines the next possible states and what to do. There is a problem with this, like how do you store this in database? You have to store each state themselves, and there's some issues. And I wanna ask you now, like, or how do we feel? It feels kind of weird, right? It feels, I don't have this feeling of being clean anymore. I feel kind of weird somehow. And the reason for this is, this feels kind of like Java. It feels like, oh, the state pattern. It feels like we are 73 years old and doing this. It doesn't feel PHP, right? And that's true. This is like super old, not high school, super old school things with the state pattern, and you're following UML charts and stuff. What we do in PHP, very often, we do the other implementation. We do the Mealy implementation of state machines. And I'm going to talk to you about that instead. And hopefully we kind of feel more young and fresh again. So, how would we implement this traffic light state machine? Like, it's quite simple, and it's a rhetorical question. Like, let's implement this together. So what I would do, I would start using my state machine class, and I would write something like this. I define my states, and I define a can function. Like, can I do this transaction? And then I just have a switch statement. And this switch statement basically says, like, if I have a transition called toYellow, I'm checking if I'm in state green, then yes, I can do toYellow. And aside from my can function, I want to have an apply function that does pretty much the same thing. Like if someone says apply toYellow, I also change the state. Does it make sense? I'm gonna quickly jump over here and see my comments. Yeah, but we have an issue here. We have an issue there. We have a private state. So somehow we need to store this state machine in the database. Right? And we don't want to store, the state machine shouldn't really hold state. I don't want to store the state machine in the database. So instead of using apply transition, we can be a little smarter. We can include the traffic light object there, because the traffic light object, we stored it in the database already. So we take the state from the traffic light object and then do the same logic. Same thing with the apply function. We take the traffic light state from the traffic light object, and then we just set the state whenever we want to set the state. So with this, I feel like we have some kind of momentum now, right? This feels way better, and I feel pretty good about my implementation. So I could be encouraged to do something like this. Like I want to have a function to allow more traffic. Like if we are in red, you will push yourself to green, and if you're we push yourself towards green, so you push yourself to yellow, and if you're in yellow, you push yourself to green. Same thing with stop the traffic. After writing this, I didn't feel as good again. I mean, it works, it's okay, but it's a little bit messy. I mean, you have transactions all over the place, and it's hard. You cannot reduce this state machine for anything. This is a traffic light state machine. You couldn't use this state machine for anything else. So, should we try to make it a little more reusable? Yeah, let's do it a little more. Let's make it more reusable. And the first thing, obviously, we need to do is we need to remove this. And we could clean up the code a little bit. Maybe we should put the states in a property like this. And that will clean up the can and apply function. And if you're smart how you do your array, you can do can with an is set. There are hundreds of ways of doing this, but you see that I cleaned up. You don't have transitions all over the place. And I can, oh yeah. But I can be even smarter. Instead of having them in a private property, I can inject the states or the transitions. Because now I can use this state machine for all kinds of traffic lights, because not all traffic lights work the same. Or I can be even smarter than that. See, I have a canned traffic light, but if I use the dependency inversion principle, instead of having a traffic light object there, I could do like a state-aware interface that has a get current state and set state method. And now I've built a state machine that works with any kind of, now I've built a state machine class that works with any kind of state machine. This is not tied to traffic lights anymore. And what we actually done here now, we basically built the workflow component. Symfony workflow component is not more complicated than this. Sure, it's better handling edge cases, but we basically built it already. There are 4 important functions in the Symfony workflow component. I think there's 5 in total, but it's 4 important ones. It's the 2 ones already seen, and I think we all can maybe imagine how to build the second 2 ones. But this is like the full workflow component. So let's see what happens in code, like how it actually looks. Consider my state machine again. You all recognize this one. If I make it a little bit smaller and I put myself in the draft, I do something like this. I take my state machine from the dependency injection container, and I want to ask, where am I basically? What are my current places? So I say state machine get marking get places, and this marking it's an abstraction over where I am. So either you can, it's an abstraction over where you are. You should be aware of it, but you rarely ever use it. So the marking is a way to get the places from the state machine. And this outputs you're in draft, and then I can do can publish, and I will get false. Then I can do to review, then I get true, and then actually apply to review, and then I get there. And here I can trash and untrash and go to review again. And then I can ask, what are my current valid transitions? And the state machine says that, oh, you can do publish and trash. The workflow component is not much more complicated than this, which is a great thing. I mean, I like the workflow component because it's so small. And since this is a Symfony component, we obviously have Twig integrations. Like, this is the same thing I showed you, but in Twig. And this is kind of cool. I mean, in my application, we have a lot of job adverts, and where you edit the job adverts, it looks like WordPress. Basically, you have your big edit text here, and then you have your sidebar. And this is the Twig for that sidebar. So if you can send it to review, you show the link of send to review. If you can publish it, you show the publish link, etc., etc. So which means the same sidebar could have 2 different appearances depending on the state of the object. So looking at this, again, looking at this workflow, if you look at it like 6 times now already, and you may wonder, how come I cannot trash something that's in draft? And that's a valid question. And there's no good answer to it. Like, of course you should be able to trash something that's in draft. So what we do is, we add this little arrow here. And here's the cool thing. I changed the state machine. I changed the state machine configuration. I did not change my code. I did not change my Twig. I did not change my controllers. I did not change my model. I only changed the configuration, and it works. Now my sidebar will be updated automatically. Like, it will show the trash link, and everything works. And that's pretty cool, and I hope you're all appreciating that. Okay, sorry. And you just add the arrow, and everything works. Woo! So you're adding the configuration, and speaking about configuration, If you configure this workflow, it looks like this. I'm just saying I'm going to use a state machine. Here's my entity. Here's the places I have, and here are how you move between those places. And if you listen to me super carefully, you'll see that something weird going on here. I'll give you a small hint. I said a state machine transition can only have one input and one output. Here I clearly have two inputs. But Symfony is smart enough to realize, like, hey, you have two inputs, you must mean that you want two transitions named trash. And that's what Symfony does for you. I have two transitions named trash. Cool. Let's consider this state machine. Business says that we need to have a 4-step, 5-step sign-up form. That's how it is. So how to make this state machine in configuration? We just says, here are places, here's the transition. Everything is fine. But then business says, yeah, but I want you to be able to go back and forth. No, forth and back. But how can we configure this? Like we have this is not valid, obviously, because we all know YAML, and you cannot have keys with the same name on the same level. So how you handle this, you basically introduce the name key. So this thing doesn't matter as long as you use the name. So this is how you can get around the limitations of YAML. And, wait. Let's rewind to this. It says workflows. I've been here for almost half an hour now. I've been talking about state machines all the time. And why does the configuration says workflow? Why is it called a workflow component? You remember this? A state machine is just a reduced workflow. And this is an example from Gregory. I don't know. He made this example to demonstrate a workflow. So basically, a workflow, this is how you publish an article. So you are in draft, you do the transitions, request a review, you get into two places at the same time. This is unique for the workflow. You can be in two places at the same time. And the spell checker is probably automatic and quick, so it's automatic and quick. And then you have to wait for a journalist. If I try to publish this now, I cannot, because the publish action needs two inputs, like approve from spell checker and approve from journalist. So publish would say, no, I cannot do publish. I need to wait for the journalist first, and now I can publish it. So a state machine you can be in only one place at the same time. A workflow can be more places at the same time. That's the strict mathematical differences. A workflow usually describes a process, like you have a start and you have a goal. A state machine that's not needed in a state machine. A state machine is like the traffic light. There's no start or goal in traffic light. You just go back and forth forever. When this state workflow component first got announced, I was super excited. Like, this is a great component. Now I can use my state machines. I also submitted a talk to SymfonyCon. I got accepted. First time SymfonyCon I got accepted. I was super thrilled. And I got to talk about state machines in the workflow component. So I was super excited, and a few months before, like 3 months before the conference, I started doing my talk, which is super early. But I was so excited. And then I realized the workflow component did not support state machines. Like, not at all. So I was in panic, like I have a talk in 3 months and the code doesn't support me. So I added a bunch of pull requests, and we discussed a lot with Gregory, who is the author of the component, like, hey, why and how we need to include state machines. And we got stuck in the discussions like, what's the difference? What's the difference between a state machine and a workflow? And except for the more than one place at once, there is really no difference. So if you ask me, when should I use a state machine, when should I use a workflow, it basically comes back, it's a matter of taste. Like I told you, a workflow usually describes a process. It doesn't have to. A workflow usually don't have loops, but it can, and that's valid. But it doesn't really matter what you use, and in 99% of the cases you can use either or. But I think you need to know what you're using, because I relate to the objects differently. Workflows are a little bit more advanced, and state machines are simplified. I use state machine for most things. Yeah, I use state machine for most things because I like them. It's no more argument than that. Okay, back to the talk. The workflow component is a component like every other component, and you know, Symfony has like 30 different components. They all are super independent, but they work really well together, right? And if you don't know, or I can tell you how they work really well together, is they're using events. And the workflow component is no exception to this. It uses plenty of events. Every time you do a transition, you fire like 21 different events. So there's an event for every time you leave a node, there's an event called workflow leave. And every time you leave the job advert state machine, it's a workflow job advert leave. And every time you need a specific node, there's a workflow job advert leave draft. So these three events are dispatched whenever you leave a node. And then you have the transition event that's being dispatched, like this transition is happening, and you have the same structure. Same with all these, like you have the workflow enter a node, you have the workflow entered a node, and you have the workflow completed, and you have the workflow announce. And it may seem ridiculous that we need so many events, and yes, it is ridiculous. I reviewed all the like the first version had 3 events, and then they added the other 4. And they all make sense in some edge cases. You probably won't need all of them. Documentation, this is pretty good. So, but it's plenty of event dispatched, and this, or even an extra guard event dispatch. So, I need more space. So the guard event is basically a way for you to use some external or dynamic logic. Like you define your state machines and workflow and stuff, but if you're not allowed to publish something, for example, if you don't have the role publisher, or maybe you're not allowed to publish if the database is offline, or if it's not between 12 and 5 p.m., or maybe you're not allowed to publish if the manager is not in the office, etc. If you got such weird rules, or strange rules, or dynamic rules, you put them in a guard event. And this guard event is just a normal event subscriber interface, and it listens to this event. You can also use this event for logging. Like here I am logging everything whenever I leave a node in the job advert. And again, it's a normal Symfony event subscriber, and I just add a lot of logging messages to make sure I can follow in my application what happens. I do also use these workflows in my security voters. Like if someone publishes an advert in my system, it should be allowed for anyone to see, but only if it's published. Like only if it has the state published. And this is what I'm checking here. Like you're allowed to you're allowed to view it if the state machine for this advert has published. Same thing, I'm using these events for domain object. I mean, this is my domain events as well. So I hook into these. So I know when every time I publish an advert, I will dispatch the workflow job advert enter published. And that's maybe I want to tell the world and say that something's published. So I'm using these as my domain events. Whenever me and my team decides that we need a new workflow or we need a new state machine, we are discussing and we're standing on the whiteboard, like drawing things. Like this is how we think it should look like, and then we change the circles, and then we discuss for a while. And when we're finally happy with how the workflow looks like on the whiteboard, we write the configuration, and then we run this command. This command basically gives us this image. So you see this Unix pipe here. What I'm basically doing is the first part saying, dump this as some text, and then use the dot, which is part of GraphWiz, to take this text and make an image of. So I have my whiteboard, and then I have this image. And I'm looking at my whiteboard, and looking at the image, looking at my whiteboard, looking at the image, and then I see these are not the same. So more often than not, I wrote something different in my configuration. So I update my configuration, then run this again to make sure the whiteboard looks as I expect the code to look. So this is a great way to debug your configuration. So, state machines are great, but how do you actually apply them? I mean, it could be hard at first, like where do I put my state machine and where do I need a state machine, but you could learn to identify the needs. Like here are some easy picks. Like I wrote a CRM system once and we have quotations, and I wrote constants, like here are 4 constants for status or states where I can have my quotation in. I even have a private property called status. Like if you see these kind of pattern in your code, then maybe it's a good fit for a state machine. And you could argue, like, Tobias, do I really need a state machine if I only have 4 states? And I don't know. I mean, that's maybe on the limit to be a little bit too little. But since this is a CRM system for a custom customer, like, you probably know that this is gonna grow eventually. Like, this is gonna be bigger. So it could be a very good idea to implement state machine here, even if it's super small and super simple. Whenever you have this pattern, like this is the database, I have a bunch of objects and I have booleans, like this define, like this is active, this ended, or is this closed? Like in this code, this is a I usually say when I'm presentation like this, oh, this is old code of mine, blah, 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 I use state machines now. But honestly, I don't use state machines. This is current code as well. I even fake the dates so it looks very old. But this is current code, and every time I'm using this class, I'm like, what does closed mean? How does closed differ from ended? And I have a lot of logic to kind of figure out this and to move between states. This is definitely a case where I should refactor and use a state machine instead. So how about processes? Like I said, multi-step forms can also be modeled as state machines or workflow. So a normal process is obviously every e-commerce site. So in every e-commerce, I don't do e-commerce, but I imagine every e-commerce site, you do something like this. An order is created, you add items or products to that order, and then you set the delivery address, and then the user goes to the checkout, enter the payment details, and then you have to notify the delivery people that, hey, you should ship this product. So in a state machine, we're doing this as a workflow. You create the place, and you could add items, and then you can add shipping and checkout and order confirmed. But this workflow only allows me to add 1 item, right? So I do something like this, so I can add multiple items. So when the customer goes through this, you have created, add item, and then add item again, and then I go shipping address, checkout, order confirmed, and what happens here, I fire an event. Or for all of these, I fire events, but this one is interesting, this one I want to listen to. And I have my event subscriber looking like this. Whenever workflow, checkout, order confirmed, announced, then use a delivery service to make sure to take care of this order. So now we know that no order will ever be confirmed without this event being dispatched. That's like this workflow guarantee. So this is why I can use this as a domain event. So yeah, with this workflow I can guarantee that, with this workflow I can also guarantee that no order will ever be created, I will never have a confirmed order without the shipping address. Right? Because I probably have a guard here that makes sure I have shipping address need to be added before I can do this transition. So, using the Symfony workflow component, I mean, you will definitely help you to write fewer bugs. And I hope this short talk of mine have given you like a way of thinking, a way to relate to your problems. Thank you very much.